Hey, welcome to my channel. In this video, I'll be covering the basics of Firebase Cloud Firestore and how to deal with the database through a server side. Dealing with the database in Firebase Cloud Firestore is the same as doing it from the client side when it comes to the code of reading or modifying data. That being said, the main difference between the two methods is that in the first case, users interact directly with the database from their browsers. However, in the second way, users send HTTP requests to a backend that is responsible for dealing with the data before sending it or getting it from the database and sending it back to the user's clients. Check the article in the description below for more details. First and foremost, we need to create a very basic node.js app with Express installed to handle the different HTTP requests. The first step to include the different Firebase configuration and functionalities is to install the Firebase admin package. Now we need to create a project in a database on the Firebase console. Go to Project Settings, the Service Account tab, then make sure that Node.js is selected and generate a new private key. Copy the code and paste it in your app.js file. Then set the path of your downloaded JSON file to the service account variable. That should do the work. However, there is another method to do the same which is recommended by the Firebase team since it's more secure. Just change the search function by the default application function and type the following command every time you open a new terminal session. Then the final thing is to add Axios to the front-end part of the project to send the different HTTP requests. Data in Firebase Cloud Firestore is stored in a form of collections. Each collection is composed of different types of data. It might be a boolean, a number, a string, etc. Or a nested collection which itself is composed of a number of documents, and so on. In JavaScript, to get the reference of a collection, we have to use the collection method, and to get the reference or location of a document, we need to use the doc method. So, to add data to the database, we need to get it first from the form and then send it to the backend using an HTTP request. I'm using the number function because if I don't, the value of the age property will be considered a string instead of an actual number. Now, in the backend, we need to add the post request, which in the body of its callback function, we will add the Firestore code. First off, we need to create an instance of Firestore which contains the different methods to save, read, update, and delete data from the database. Now, to save the data, we need to create a reference to the collection and the document where we want the data to be saved, then call the set method. Set takes an object that holds the data as parameter, and the value of each property needs to be filled from the request using rack.body.thePropertyName. I'll separate the collection reference in a constant since I'll be using it during all of this tutorial. We can automatically generate documents IDs instead of hard coding them through the add method instead of set. Or we can use the doc method without a parameter to create a document with an auto-generated ID and store it in a constant, then filling it later with the necessary data calling the set method. Now, let's say I want to add the type field to the user01 document. If I use set as previously done, the document will be overwritten. Therefore, to add data to the document if it doesn't already exist, we have to set the merge property to true, which is contained in an object that is passed as second parameter to the set method. As we previously did with add, Let's use Axios to send the different data collected from the HTML form to the backend. Now, to update the different fields in the database, we have to use the update method. We can skip using then and catch for now. To update an object field, we need to use the object name followed by a dot and the property name, because if we use the object name then the field inside the curly braces notation, all of the old data inside the object will be overwritten, not only the property. Arrays also have their own way to be updated, so to add a new value to an array field, we need to use the array union function. To delete a value from an array field, we need to use the array remove function. Speaking of functions, there's a bunch of useful prebuilt functions that we can use to set data. Server timestamp is one of them. This function tracks when the server receives the update. There is also the increment function, which we can use to increment or decrement numeric values. We can delete a specific field in a document using the delete function within the update method. On the other hand, to delete an entire document, we need to use the delete method on the document reference. To get the data of a document, we need to use the get method on the document's reference. To get all documents data within a collection, we need to call the get method on the collection's reference. User.id holds the ID of the document, and the data function returns the document's data. To retrieve documents that respond to a certain criterion, we can use the where method, which is similar to the where clause in SQL databases. Where has three parameters: The first one is the field that we want to query on, the second one is the query operator, and the third is the value to look for. We can chain multiple queries. However, the field should be the same in each where call. In this example, as you can see, I used the age field in both of the where calls. Arrays have their own querying operators. So, to query based on a value of an array, we can use the query contains operator to get every document that has a certain value in its array field. We can also define an array of values to look for. Thus, if a documents field has one or more values that belong to the array of comparison that we defined, the document will be selected. In this case, we need to use the array contains any operator. Now, to get all the documents within every subcollection that is nested in each document of a collection and that respond to a certain query, we need to use the subcollection method. An index must be set to get such a query working. To do that automatically, click on the link provided in the error message. We can attach listeners to documents to tell whenever they get updated or deleted or even added using the onSnapshot method. The data function returns the new data of the document after it gets updated or added. We can attach the listeners only to documents that respond to a certain query using the where method. To figure out what event has occurred on documents, we need to add the docChanges function, which returns the list of changes that happened on each document. Change.type contains the individual change. Its value could be changed, added, or removed. This should be enough to get you started with Firebase Cloud Firestore, yet there's way more to learn about, since it has other features, and especially the security roles, which are essential for the security of your database. Make sure to subscribe and see you in the next one.